Now, if we can have uh, pointers to arrays, if we can have pointers to integers, we can also have pointers to objects. For example, if yeah, the same example we would take. We have a class called as simple, and we have a public, let us say we have a public member, data member A. Now what we are doing, we are creating an object of that class obj, and we are creating a pointer of the same type. Now observe this. Am I allowed to create a pointer of integer type? Yes. Int is a built-in type, and I'm allowed to create pointers of any built-in type. Similarly, if I say P is my pointer, but it is of class simple, will it be allowed? Yes. This is a pointer of user-defined type. But since P can only point at integer type of variables, so this P will be able to point at only simple type of variables, and simple type of variables are nothing but objects. Any variable having user defined type is called as an object. Similarly, we have declared a pointer over here of simple type, and then we are initializing ptr with the address of object of the same type, simple type. Understood? So the object is created whose name is obj, having obviously it's having only one data member, and ptr is pointing to that object. Now if I want, I can access, since this is public, if I want, I can say obj.a from the main. I can access it like this since it is public. But this is direct accessing, right? If I want indirect accessing, I will say ptr arrow a. Suppose I want to display. Yeah, the same thing is done. Clear? Pointer should also be of the simple type simply because pointer ptr will carry the address of the same type. If I say int ptr and then I say ptr is equal to address of some object obj, it is not allowed because pointer and the variable or the object to which it is pointing, those two should be of the same type.
So like
Understood?
normal data.
Whatever it is, whatever address, if obj was an integer variable, then this would be correct. But obj is a object, user defined type of variable. That is why ptr, the pointer which is trying to point at the address of obj, that pointer should also have the same data type. Understood? Important topic, very essential topic, because generally what we do for a given class, let us consider the same class. If we want to create objects, we'll create like this. Sorry, S2, S3, right? But this is not the correct way. If we want multiple objects, what we tried? We tried this way, S of 5, for example. So if we want 5 objects, let us create an array of objects, right? It will have 4 different objects, sorry, 5 different objects, and each object will have its own set of data members as usual. But again, we are not sure that we want to create 5 objects or more than that or less than that. Understood? So that is why we can create a pointer sorry, simple pointer P, and that will point at some random set of objects. Now what value will come here? Let us say n. So that n we can accept from the user. Can we accept the size here from user? Sorry. No. Can we declare, I mean, simple of n, because n is not having any value at that point of time, right? So a new way is to create a pointer to the object and then create as many objects as we want. I mean, we are reserving space for as many objects as we want. And amongst those n objects that we are creating through the new operator, the first object will be pointed by P. Now, if I want to access the first object, I'll say P of 0 dot any function name get, whatever it is. Then if I want second object, I'll say P of 2 dot any function name may be display, likewise. So this is the importance of pointer to objects. Yeah, sorry. Since it is a pointer, not the dot symbol, but the arrow symbol. Yeah. Okay. Yeah, the same things we are seeing. Why basically pointer to objects are used? They are used to create objects at runtime. How we create objects at runtime? Okay. How did we create uh, variables at runtime? If you remember, you must have done this in practical. We are in the second practical, we were asked to use the new keyword, right? So what we did, we can create a variable dynamically at runtime by mentioning new int, right? But the variable, I mean, we can reserve a space for an integer variable by mentioning new int. But wherever that variable will be created at runtime, I need some way to access that location. Okay? So whatever is the address. So that address is returned and that is stored in the pointer. So generally, if we want to create variables at runtime, we use a pointer so that the address which is at which the runtime of variable is created, that address can be accommodated in the pointer. Similarly, if we want to create objects at runtime, we can do the same. Here I've taken an example. So we are having a pointer PTR of the type sample class. Now, PTR will always hold address of any object, but the type of that object should be what? Same, sample class. What is the type of pointer? Same should be the type of the object. Yeah. Here we are storing the address of obj in PTR. Then now this is how what we can store the address of object into a pointer, but the object already exists. We are not creating the object at runtime. The object was created by us explicitly, and then we are assigning the address. But as I explained earlier, uh, yeah, in this case, all the member functions will be accessed through the pointer using a arrow operator like this. And uh, as I told, we can create objects at runtime using new operator and refer to it using a pointer. So this is how we are trying to do it. The same way, sample class, a pointer of sample class type, and the pointer is initialized with the address of a new object that is created at runtime. New object of sample class type was created and the address of that object was assigned to PTR. Clear? Now, if we want, we can even pass parameters because we know when we are creating objects, suppose I created object of class A and I required some parameters to be passed, maybe integers, maybe whatever data type, maybe even object. Let us create object A2 and pass A1 to it, right? This is also argument. So if that is possible, definitely when I create objects at runtime, there also the object what I am creating at runtime may require some values to get initialized, to initialize the objects of the newly created, to initialize the data members of newly created object. So we can pass parameters for object creation. This is how we can do it. What we are doing, everything remains the same, just we are passing some parameters, a required number and type of parameters, so that whatever new object got created, its two data members, maybe X and Y, we'll suppose, got initialized with 5 and 10 respectively. But this object, newly created object, is not having any name. Like A1 was the name, A2 was the name. This newly created object, dynamically created object, is not having any name. The only way we can access that object is by using the pointer which stores the address to that object. So PTR points to that object, newly dynamically created object. Clear? I hope the importance of pointers to object is clear. Minute. As I told, we are using it to create objects at runtime. This concept is used to create objects at runtime. And when we create objects at runtime, we are binding the functions with any particular class at runtime. For example, if I say I have a class A and I create object of class A, and then I say A dot maybe display, right? So which display should get called, that is decided at compile time. When the compiler is compiling your program, it decides that display function from class A needs to be called because the calling entity is what? Calling entity is A1 and A1's type is A, right? So this is called as compile time binding or static binding, right? But in case of unnamed objects like we created with the new keyword, can we have this binding at compile time? No, because there's no name given to the object. So how we can decide what is the type of that unnamed object? Understood. That is why uh, runtime binding can be achieved with the help of pointers to objects.